AC. So mg into L by 2 should be equal to IO alpha. From that we'll get alpha. Then AC equal to L by 2 alpha. Then mg minus ry equal to mac. So what is the reaction at the end just after relieved? Or going for the semicircular wire. The same methodology, nothing big will be there. This is hinge. Okay, just try to. I want you to think once. Then I'll come into the center of mass of the wire. We must have some basics. So in exam, you can't find out center of mass of the semicircular wire. Okay, this is the point P. So the weight. Okay, I said 2 minutes. No. Okay, I'll let me wait for some time.
Sir, mg by 3 pi under root
Now,
of pi square plus 16.
Root of pi square plus 16 by 16. Huh?
Sir, mg by 3 pi under root of pi square plus 16.
Oh, that much is not there. Okay, we'll see. Okay, anyway, you try. No, okay, fine, good. Weight of the this will mg. Here, why there's no reaction along x-axis? There's a primary question. If you can ask, problem solved.
No force along x-axis.
Because there is no other anybody is there to pull this rod radially outward or to push this rod radially inward. If I give angular velocity, there'll be reaction. Please check in notes. I think we have discussed long back. Here, if I release from rest, just after released, from rest, if I release this rod from rest, no reaction along axis. If I give angular velocity and release, there'll be reaction will come. Here also, sir, release from rest, so therefore there'll be only Ry. Okay, in fact, here you see that how the motion of center of mass will be. How center of mass will not move vertically down here. So what is the type of motion this wire will describe? It's a pure rotational motion, no, about point P. So how the acceleration of center of mass will be directed like this here. Perpendicular, this is R, this is theta. So this let me call Y, YC, or that one, this is small. Okay, this is capital R. What is Y? Y is equal to 2R by pi. Now you see that there is a m component of acceleration of center of mass along x-axis is there. So there should be reaction. So there'll be reaction.
mg into root of 1 by 4 plus 1 by pi square.
Okay, then yeah, that will be correct. Okay, nx and ny will be there. That will be correct here. So let's write the equations of motion. So this is theta is what I took it. So this is theta, this is theta, this will be theta. No. So mg minus ny equal to mac cos theta. Then nx should be equal to mac sin theta. Then we'll write equation for torque about point P. So first let me start with the torque one. Torque about point P should be equal to IP into alpha P. Then what is the torque about point P? So mg into r, because this nx and ny will intersect axis of rotation. So mg into r should be equal to, I want IP, that one. For that, I should know ICZ. So this is like a x-axis. This is a y-axis, no? So what is IOZ? mr square. So therefore IOZ equal to ICZ plus m into y whole square. IOZ is mr square ICZ m into 2r by pi whole square. After getting ICZ, now you'll get IPZ. IPZ equal to ICZ plus mr square. What is R? R is, again, I should write it as root of r square plus y square. Okay, now, so this I got IPZ. This I had to substitute here. Okay, after getting alpha P, then I'll get AC. What is AC? AC should be equal to R into alpha P. After getting AC, then let me write equation. mg AC cos theta, AC sin theta. Okay, now nx and ny, solve for it. The total reaction will be solve all the equation. I'll begin with the, I'll just give the end answer. Okay, now what is the thing? So let any other rigid body, let it be released, no? So don't think that always it'll be along y-axis, the reaction. It all depends upon the shape of the rigid body also. No, you explore. Okay, if I release, I want students to really understand. So if I release a disk, then instead what happened, let me release a triangle. Equilateral triangle, you can take it. or if I release a triangle. So it's unlimited. See, that's what I suggest you, like. So same thing. So there's a right angle triangle, 30 degrees, I'll give it. Other things and also let M be the mass. What about the reaction then? So many things are there, no? The lamina, triangular lamina. So many shaped objects can come. So even they can bring some particle here, they'll attach some particle. It'll become unlimited. So at least I think this is a one case, that one. This is not a generalized one. Huh? No, this will become some sort of like generalized. We have books, more discussion on the rod. You see, total 90% of questions in the textbooks are based on the rod. Along with the rod, in every problem, in case of rod, if it is any other rigid body there, what will happen? Think once, no, definitely I think you'll be in better position. So try to work out. If it is like a disc is there, ring is there, ring or semicircular plate, both are same idea. Triangular plate will come, or any other cone also I can release. That will be little bit what will be the reaction at the hinge. So there is a one methodology of revising rotation mechanics. Please go through. Even you may feel you are doing less problem, but at least clarity will be there. You know, to struggle with every question. I think now at a stretch, if you look at the one paper, no, in one of the test papers in one of the institution, they'll give this. In another paper, this. In one paper, this one.
So your voice
Same.
is breaking.
I think we have to change timings. I feel. Okay, can you hear me now?
Yes, sir.
Please work out, please. More from student side than teacher side. I'm telling this one. So teacher, what happened? I'll think that okay, you can manage with every other diagram. Now it's the student's responsibility that the idea is same. Only the center of mass will be different. This one.